to find the pole locations of H of S. Now, we are interested in finding the pole locations of H of S for causal and stable H of S. Now, what is a causal and stable H of S? For causality and stability, it is required that all the poles of H of S must lie in the left half of S plane, and even the pole locations, the magnitude of the pole location is less than 1 if you want the stable H of S. The poles of H of S or H of minus R, H of minus S are obtained by finding the roots of the denominator polynomial of the magnitude square function. Now, what is the denominator polynomial of the magnitude square function? H square, it is 1 plus epsilon square Tn square S by J ohm C. This is the denominator polynomial. Now, to find the roots of this polynomial, we have to equate this polynomial to 0. So, the poles, each of the poles which are the roots of this denominator polynomial, they are designated by Sk and they consist of the real part and the imaginary part. Now, real part, let us designate it by sigma of k and the imaginary part by ohm k, where k is taking on the values from 0 to n minus 1 for 1 half, and then from n to 2n minus 1 for the other half. So, for left half plane, we need to vary k from 0 to n minus 1. Now, to find out the roots, these roots Sk for 0 to n minus 1, we have to equate this denominator polynomial to 0. Now, when I equate this to 0, I will get here cutoff frequency. Let me assume that for normalized poles, ohm C is equal to 1 radians per second. So, when we equate this polynomial now to 0, we get 1 plus epsilon square Tn square S by J is equal to 0. Now, this I can write 1 by J can be written as minus J. So, this polynomial becomes then 1 plus epsilon square Tn square minus Js is equal to 0. I take this 1 to this side, so it will become minus 1, and epsilon square also to that side. So, you will get Tn square minus Js is equal to a minus of 1 by epsilon square. So, Tn square minus Js is equal to minus 1 by epsilon square. Now, if I take the square root of this, so Tn of minus Js is equal to plus or minus J by epsilon. Now, this value of J by epsilon or the pole locations, this every pole location for the stable system, the magnitude is less than 1. Therefore, this Tn of minus Js, I can write this as cos of n, cos inverse of minus Js, which is equal to plus minus J by epsilon. Now, this cos inverse minus Js, let me assume that it can be expressed in terms of real part and imaginary part, where I consider x as the real parts minus j into y the imaginary part. So, let us assume cos inverse of minus Js is equal to x minus jy. Getting this or not? What there are the assumptions here. First, we have assumed ohm C is equal to 1 radians per second. Now, we are assuming here that cos inverse of minus Js is expressed in terms of real part and imaginary part. So, it is equal to x minus j into y. So that now the pole location Sk, I can write it as Sk is equal to, so for this, if I take the cos of both the sides here and this multiply both the sides by j, then I will get Sk or S is equal to j of cos of x minus jy. Now this I have obtained from this equation. S is equal to j cos of x minus jy. So for this equation, I am taking the cos of both the sides of this equation. So cos and cos inverse will get cancelled, and then afterwards both the sides I'll multiply by j. So j into minus j becomes 1. So this side you remain with s, and other side you will have j into cos of x minus jy. Now proceeding to find the values of x and y. So in this equation of cos inverse minus js, if I substitute s in this equation, which is j cos x minus jy here, so what you will get, this j into minus j will be plus 1. So inside here cos inverse of cos x minus jy. So cos and cos inverse here will get cancelled. So you will get here n into x minus jy. So this entire equation where plus minus j by epsilon becomes equal to cos of nx minus jny. Getting this or not? If you are not understanding and if I am little bit fast, you can inform me. So getting this, how I have got this, plus minus j epsilon is equal to cos nx minus jny. Yes? Up till this, are you getting this? Are you following me or not? Yes, anybody is having query?
No, ma'am.
Okay. So I hope that you have understood this, how I am proceeding ahead. Now we have here plus minus j by epsilon is equal to cos nx minus jny. We have seen here the pole location S is equal to j into cos of x minus jy. Now we need to find this value of x and the value of y. Now therefore we are proceeding ahead to find the value of x and y. Now for that what we are doing, this value of s we are substituting in this equation where plus minus j by epsilon is equal to cos of n into cos inverse minus js. So therefore we are here getting this as plus minus j by epsilon is equal to cos nx minus jny. Now apply the rule of trigonometry for cos a minus cos b and expand this. So I'll get plus minus j by epsilon is equal to cos nx cos hyperbolic ny plus j into sin nx sin hyperbolic ny. Now cos hyperbolic and sin hyperbolic, how you get this? For cos of j ny is cos hyperbolic ny, and for sin of j ny is j into sin hyperbolic ny. So this plus minus j by epsilon cos nx cos hyperbolic ny plus j into sin nx sin hyperbolic ny you get. Now if we equate the imaginary and real part of both sides of this equation, you will observe that cos nx cos hyperbolic ny is equal to 0 because real part to this side is 0. So if I equate the real part, cos nx cos hyperbolic ny is equal to 0. Now when you equate the imaginary terms, so j sin nx sin hyperbolic ny is equal to plus minus j by epsilon. Now for the first equation, for real value of y, cos hyperbolic ny cannot be equal to 0. So for this term, if you want this product to be equal to 0, then it is needed that cos nx must be equal to 0. So at what condition this cos nx will be equal to 0? if the value of x, this theta, if it is odd pi by 2, at that time this cos of n pi by 2 where n is odd, this value will become equal to 0. So now for that, to make it odd, we add here 2k plus 1 pi and then divided by 2 by n, so that when this x you multiply with this n will, n and n will get cancelled, and x you will always get for any value of k in terms of the odd value into pi by 2. So therefore then this cosine of nx value you always get is equal to 0. Substituting this value of x in the second equation here, if I substitute for this x, then you will get sine of odd pi by 2 and value of that is equal to 1. So therefore j and j of both sides if you get cancelled, then you will remain with sine hyperbolic ny is equal to plus minus 1 by epsilon. Now if you take both the sides the sine hyperbolic inverse, then you will remain with ny is equal to sine hyperbolic inverse 1 by epsilon, and therefore from this equation I can write y is equal to 1 by n sine hyperbolic inverse 1 by epsilon. My x is 2k plus 1 pi by 2n and y is 1 by n sine hyperbolic inverse 1 by epsilon. Therefore, the pole location sk, which is j into cos x minus jy, will be equal to minus of sin x sine hyperbolic y plus j cos x cos hyperbolic y. So you substitute the value of x and y in this and you will obtain the pole locations sk. Now this sk, which is cos x minus jy, we expand this cos a minus b rule and then multiply with j. So here you get minus sin x sine hyperbolic y plus j into cos x cos hyperbolic y. So if I write this sk in terms of real part and imaginary part, sigma k plus j ohm k, and if you compare this sigma k plus j ohm k to this equation, your sigma k is minus a sine 2k plus 1 by 2n pi. I am substituting here the value of x. Now what is this a? A is nothing but sine hyperbolic, and the value of y if you substitute, a is sine hyperbolic 1 by n sine hyperbolic inverse 1 by epsilon, and ohm k is b into cos 2k plus 1 pi by 2n. So here in this equation I am substituting value of x, and b is this part cos hyperbolic y, and then substituting the value of y, you get b is equal to cos hyperbolic 1 by n sine hyperbolic inverse 1 by epsilon. Now once you obtain these pole locations sk for the normalized filter, then h of s you can write it is equal to k divided by product of k s minus sk. Now from this you can obtain the denominator polynomial of hs, which is dn of s. Now this k is the normalizing factor, and to find this k of this numerator k, which is a normalizing factor, we have to substitute s is equal to 0 in the denominator of h of s, that is dn of s. So for n which is odd, k is equal to dn of s for s is equal to 0, and n if it is even, then k is equal to dn of s at s is equal to 0 divided by square root of 1 plus epsilon square. So this is how you have to obtain this k, the normalizing factor for this h of s. So this k is find out from the denominator polynomial dn of s by substituting s is equal to 0 in the denominator polynomial. So for odd, you will get this as it is. But for n, if it is even, then k will be equal to this dn of s at s is equal to 0 divided by square root of 1 plus epsilon square. Now the poles of this h of s and h of minus s, here for this h of s, the poles will fall on an ellipse with major axis B ohm C and minor axis A ohm C. This you can verify once if you develop a MATLAB program for Chebyshev filter, then magnitude response you can plot and the pole locations also you can plot against real part and imaginary part, and you will observe that these poles lie on an ellipse with major axis is equal to B ohm C and the minor axis is equal to A ohm C. See here, this is a major axis for this ellipse which is B ohm C and minor axis is A ohm C. So this is for this h of s which I have just now explained to you, which is obtained from this h of s is obtained from pole locations which is in the form k by dn of s. The k is the normalizing factor, and for n odd k is equal to dn of s at s is equal to 0, and for n even k is equal to dn of s at s is equal to 0 divided by square root of 1 plus epsilon square. Now difference between the Chebyshev and Butterworth filter is that in h of s, in this case of Chebyshev filter, you have to add k, a normalizing factor here in the numerator, whereas for Butterworth filter we write this h of s in the format of 1 by product of ks minus sk. So I hope that you have understood this derivation of finding h of s and the h of s pole location and writing h of s in terms of the pole locations which are computed. So proceeding ahead with then for solving a problem on designing a type 1 Chebyshev analog filter, which is a low pass filter which has a 3 dB cutoff frequency at 100 radians per second and stop band attenuation at 25 dB, or it is greater for all radian frequencies past 250 radians per second. So stop band attenuation, that is AS, is 25 dB, AP is 3 dB, ohm P is 100 radians per second, and ohm S is 250 radians per second. Now these are the attenuations, so you have to take this AP as minus 3 dB and AS as minus 25 dB. Now from this AP and AS, we need to find epsilon and lambda. Therefore, epsilon is equal to square root of 10 to the power of minus 0.1 AP minus 1. Now, these equations finding epsilon and lambda are same for Butterworth filter as well as for Chebyshev filter. Why it is same? Because the magnitude square function at ohm P is, in both cases it is considered as 1 by 1 plus epsilon square, and then if you convert it in decibels the attenuation is in AP. So from AP you find epsilon, and similarly lambda magnitude square at ohm s is 1 by 1 plus lambda square. So the magnitude, if you convert in decibels, it is AS, and then from AS you need to obtain lambda in a similar way how we have done it for the Butterworth filter. So the equations are same for Butterworth filter as well as Chebyshev filter, finding epsilon and lambda. Now here in this case epsilon is equal to 10 to the power of minus 0.1 AP minus 1, AP is minus 3, so it is square root of 10 to the power 0.3 minus 1. Now you use your calculators, find this value of epsilon and tell me the value of epsilon. Use your calculators. Those who finish first can unmute your mic and tell me the value. Compute first 10 to the power 0.3 and subtract 1 from that and take square root of it. What is the value? One. It is 1 only.
1.
1 only. Okay. 0.9976. You can take it as 1.
Yes.
Yeah, you can take it as 1. So most of you are getting 1. That is good. Now for lambda, it is square root of 10 to the power minus 0.1 as minus 1. Now as is 25 minus 25. So when you substitute as here, you will get 10 to the power of 2.5. Then use your calculators and find 10 to the power 2.5. Subtract 1 from it and take a square root of it and obtain lambda.
17.75.
17.75, right? So we have now epsilon and lambda. We shall substitute it in the equation of n. Now we have n is equal to cos hyperbolic inverse lambda by epsilon upon cos hyperbolic inverse ohm s by ohm p. Ohm s is 250 radians per second. Ohm p is 100 radians per second. We have here epsilon and lambda. So first let us compute the ratio lambda by epsilon. So I have already computed here. Lambda by epsilon is equal to 17.7931 and the ratio of ohm s by ohm p, that is 250 by 100, it is 2.5. Now substitute this value of lambda by epsilon here, which is 17.7931 and ohm s by ohm p is 2.5. So n is equal to cos hyperbolic inverse 17.75 divided by cos hyperbolic inverse 2.5. Now in your calculator, this direct function is available, cos hyperbolic inverse. So from that, you use that and find out the ratio and tell me the value of n. So doing it or not? I will get this value of n is equal to 2.279. You have to select n is equal to 3. Is there function, this cos hyperbolic inverse function is available in your calculator or not? You have cos hyperbolic inverse and there shift and cos hyperbolic inverse you will have. Is it there or not in your calculators?
Yes, ma'am.
So are you getting the same value?
Yes, ma'am. 2.27.
Good. So now let us select n is equal to 3 because we have to consider the next largest integer value. So we are selecting n is equal to 3. Now to find the poles of HS, which are by this equation we find where Sk is equal to sigma k plus j ohm k, where sigma k is the real part of the pole location and ohm k the imaginary part, where sigma k again is equal to minus a sine 2k plus 1 pi by 2n. Now here n is equal to 3, so we have to substitute n, and ohm k is equal to b cos of 2k plus 1 pi by 2n, n we have to substitute 3, k we have to vary from 0 to 2. Total 3 numbers of poles we have to find, where a is equal to sine hyperbolic 1 by n sine hyperbolic inverse 1 by epsilon, and b is equal to cos hyperbolic 1 by n sine hyperbolic inverse 1 by epsilon. Now before proceeding ahead with finding sigma k and ohm k, we shall compute these values of a and b. So for that we have epsilon. Take a ratio 1 by epsilon first. So 1 by epsilon is equal to 1 only. If you have got 1, you can select this as 1 only. And n you substitute is equal to 3 and find a. So a is equal to sine hyperbolic 1 by 3 sine hyperbolic inverse 1. So use your calculator and find this value of a. First find sine hyperbolic inverse of 1 and to that you divide by 3, and for answer you take the sine hyperbolic. Those who finish, you can tell me the value of A.
Point 29.
So 0.29 you have this A is equal to. Similarly, let us obtain B, which is cos hyperbolic 1 by 3 sine hyperbolic inverse 1. So you have already computed sine hyperbolic inverse 1 and divided it by 3. This value you obtain cos hyperbolic of that value or bracket value, so that you get B.
0.95.
0.95. Okay. Here I have taken here 1.0024. So I am getting here 1.043. 0.95 or 0.1, they are almost nearby to each other. So now to find the pole location in this equation, we have to substitute this value of A, and for Ohm K we have to substitute the value of B. So sigma 0 is equal to A is 0.2986. So this is minus 0.2986. Sine of K, if you substitute, is equal to 0. You will get sine of pi by 6. So sine pi by 6, and ohm naught is equal to, now you have got zero point 0.9 or 1, whatever you have got, you use that, and cos pi by 6. So that S0 you write it in terms of this sigma 0 plus J ohm 0. Verify whether you also get nearby to this value. So S0 will be equal to minus 0.1493 plus J 0.9038. So sigma 0 is minus 0.2986 sine pi by 6. So use sine pi by 6 to that multiply by minus 0.2986, so that this part you get. And for ohm 0, cos pi by 6, and to that you multiply with whatever value you have got, 1 or 0.99. 0.95 if you have got, you can substitute 0.95 here. Little bit variation in the pole location you will get. Are you nearby to this? What are your values? Similarly, next for sigma 1 and ohm 1, you have to proceed. Now K is equal to 1, we substitute here. So A is minus 0.2986, and sine of, when you substitute K is equal to 1, this becomes 3 pi by 6. So sine of 3 pi by 6, which is sine of pi by 2, and cos 3 pi by 6 is cos pi by 2. Now value of cos pi by 2 is 0, and sin pi by 2 is 1. Therefore, S1 you get it as a real term, which is equal to this minus A. So S1 is equal to minus A, you get minus 0.2986. Imaginary term is 0 here, because ohm 1 you get 0. Here cos 3 pi by 6 is cos pi by 2. So cos pi by 2 is 0. Therefore ohm 1 is 0. Sin pi by 2 is 1. So sigma 1 is minus 0.2986. Next you substitute K is equal to 2. So sigma 2 is equal to minus 0.2986 sin 5 pi by 6, and ohm 2 is equal to whatever your value 0.95, if you have, you use 0.95 cos of 5 pi by 6. Now remember that this S2 should be conjugate of S0. You have to get this conjugate because they appear in conjugate. So once if you obtain the pole location, now n is equal to 3, all these are left half planes. So we have completed with 3 pole locations for left half of S plane. Now let us write H of S. Now n is odd here in this case, where H of S is equal to K by product K S minus Sk. Now for odd order, K is in Dn of S, you have to substitute S is equal to 0. Now what is Dn of S? S minus S1 if you take, it will be S plus 0.2986. This is S0 and this is S1. So S plus 0.1493 minus J 0.9038, and this S2 is S plus 0.1493 plus J 0.9038. Combining these conjugate pairs, S square plus 0.2986 S plus the square of these two value, which is plus 0.8391. So here this is 2 into this real part. So 0.1493 into 2. So you will get here 0.2986. Now in this you have to substitute S is equal to 0 so that you get K. So in this dn of S, I'll substitute S is equal to 0. Now if I substitute S is equal to 0, for the first term you will get 0.2986 and for the second bracketed term you will have 0.8391. So multiply these two and get K. Therefore, K is equal to product of these two, that is 0.2986 into 0.8391. So if you verify, you will get K is equal to 0.2505. Therefore, now my H of S is 0.2505 divided by S plus 0.2986. So S square plus 0.2986 plus 0.8391. Now this is a transfer function for a normalized filter. So for prototype filter, we have to replace S in this equation by S by 100 radians per second. Given ohm P is equal to 100 radians per second. So we shall replace this S with S by 100. So in this H of S, which is this H of S, I'll replace S with S by 100. After replacing S by 100, I'll get this denominator polynomial like this. S by 100 plus 0.2986, S by 100 square plus 0.8986 into S by 100 plus 0.8391. Now numerator and denominator, we will multiply with 100 raised to 3. So that to the first bracket I will multiply by 100 and second bracket I will multiply by 100 square. So I will get the first bracket in the denominator as S plus 0.2986 and the second bracket as S square plus 0.2986 into 100 square, that is 10,000, and then plus 0.8391, sorry, here not 100 square, it is by 100 square, if you multiply 100 you will get cancelled. So 0.2986 into 100 and 0.8391 into 100 square, that is 10,000. So you will get H of S is equal to 0.2505 into 10 raised to 6 divided by S plus 29.86 into S square plus 29.86 S plus 8391. I hope you got this.